Hey kids, it's good buddy Mark Miller here. Here to be your guide in the age of COVID. And it's in me. Right in here right now. And as a result, I'm like, we'll just do our best to, write some code, see what we can do. But, we're not going to stress it too much. That's what we're going to do. We're getting back into the Mark Flies code today with the TypeScript. I did my DevExpress duties, by hopefully creating a really killer video, showing off the callout technology we were working on yesterday. And it occurs to me, you guys might be interested in seeing that before we start doing anything else. So let me go look and bring up one of the test apps we had for that, and we'll bring that up. Loading up now. And Cody Gorilla is in. I don't want to interrupt, but fine. Oh no. Got all dressed up to get on the Empire State Building. I don't know. I don't want to complain or anything, but we're still waiting. Roy, are you with me, by the way?
Waiting. I am. I'm here.
He's with us. Kids, ladies and gentlemen, say hello to my friend, Roy. There he is. Roy's on time. He doesn't make me wait. But, I don't want to complain about the people over at Arctic in Germany that made this guy. But I'm having fantasies of destroying this thing. That's where I'm at right now.
That's not good.
I'm like at a point where I'm like, I'm going to buy another one, and somebody else is going to get, somebody else is going to get the kudos or the praise or whatever.
Mm-hmm.
Maybe you should just order a different one. Well, you know what? I went back and I looked. Let me adjust my mic just a bit. I went back and I looked closely at the order, and what I thought had been LGA 1700 kit included was LGA 1700 kit available. So it was I think technically my fault, it appeared upon further investigation. And when it's my fault, I don't like to prosecute as heavily.
Seems reasonable. Yeah.
That's just how I am. Here, we'll take a look at this. Got it working now in the new build of CodeRush, and we'll just click this button here. You can see what it looks like here. Oh, there was one issue. The issue where it's not showing up, it was happening in both. It was really a matter. I haven't actually solved this yet, but I'm not in the mood to solve it right now. But it was solved by switching the themes. Well, all I do is switch the theme like that and do it one more time, and now it works. Let me undo that because we'll go bring this theme back to black again here. It's not, you can see it's not theme to dark. It doesn't handle every situation yet. That's still, basically I just made it good enough so that I could do this, right? But it is handling the scrolls, right, like this. And if I click and move it, it's correctly, look, you can see the highlight right up there. It's giving focus back to Visual Studio. So now I can hit enter and get to the next piece. And what I love about this is it's showing me each of the pieces of the code, explaining the important parts, putting the story together, right? And showing me each piece. And I love it, right? As I go through it like that. Yeah, no, it's really nice. And so that's kind of what we've been working on, and that's what it looks like in fruition. And I'm just loving it. By the way, there's your suggestion is featured prominently here, Rory. Right? Are you noticing that it's animating in every single one of these? Really nice suggestion.
Like that.
Yeah, that's really nice. That clicks and runs the application, which probably won't work because I just jumped right ahead into the middle. And because I wanted to demo this page. So anyway, that's cool. The other thing, Lindor! everybody. Everybody gets salt. Thindall, welcome.
Hey, Thindo. Long time no see. Feels like
Thindall's
it.
like, I missed you, Fred. And he's like, oh, and hi to you, Mark, too. And I'm like, me? Oh, well, hi. I know people are here just to see Fred. Isn't that right, Fred? Yeah, he says, yeah, that's right. Okay. I'm not sure what that's about, but okay. Jonathan DeFraze is out there. How you doing, Jonathan? Welcome. Glad you're with us. We're not, promising a whole lot today. Maybe some of this. Yeah. No, what you're thinking.
You got the perfect shirt for that particular party. You matched every single phase.
That's awesome. That's awesome. I didn't notice that. Thanks, Roy. Yeah, I just want to say, I know what you're thinking. You're thinking, why is Mark spending all his time writing code? He should be a professional dance choreographer.
That's the one. Yeah. We're all just amazed.
Someone was thinking that. Jonathan says, good, been a while, good to catch you live. Well, it's good to be caught live. There's a second one I wanted to show. Is it here? No. Here. This one, this is what I love about this technology. So this code used to be loaded with comments to explain everything. Yeah. And then because we need to combine documentation with code, right? Mm-hmm. Well, all of those comments go away. And now something that was like, 2 or 3 times as long is now just consolidated into 3 lines of code here. But we get you the text we need to explain what's happening at each point. Isn't that nice? I love it.
It's good. Yeah.
Yeah, it's really cool. I did some recording today. That's technology we're wrapping up. I'll close that down. Not going to save anything, and we're going to do our best to get back into here. Now, I'm not promising anything. The show is sponsored by... Force and ignorance. So there's nothing we can do, right? It's also sponsored by some frogs, too. And I have to give them airtime. It's part of the contract. So it's nothing I can do. Nothing I can do. We're going to try. You forgot the cookies. What cookies are we talking about? By the way, yesterday, 2 days ago, I think, I got wasn't feeling well. My wife had not been feeling well a couple days before that. And I was like, I'm going to take a COVID test. And they're like, oh, Mr. COVID's taking a COVID test. And so I took the COVID test, and it was positive. And I was like, and not only was it positive, it rushed. It was like the instructions say, wait 15, 20 minutes if you see a faint line. It was like, he's got it. And so so that happened. And today I'm noticing I'm kind of like just sleepy. I just want to like close my eyes. Yesterday I was fine, I think, relatively good. But today I'm like, I am a little sleepy. So I'm not promising anything. There are no promises on this code today. I don't know what we're going to do. Fred, are you okay, buddy? Where are you? Did you get run over? Fred says he's okay. No promises. But I do feel like, I'll tell you what I do feel like, though. You know? I feel like this. I feel like going for a walk. Just for a minute. And we'll get back to that code. I promise. But I just want to take a walk. Breathe the air. Everything's peaceful. What the? Uh-oh. Those guys. Oh. I gotta get those guys. Where's the button? Where's my button? Oh! It's gonna be somewhere. Just gonna start hitting things. I think I got him. I can't tell, Roy, if you're like if this is entertaining or if you're just rolling your eyes like, oh, Miller, would he
It's actually
stop?
pretty good. I like it.
Would it please just stop with this? Okay, so let's see what we got. It's been a while since I've been flying these drones. We were like a week ago plus, because you know I last touched it last Thursday, I think. It's exactly a week ago. So let's see what we can do here. If I hit the launch mark button, that's me. And then I say go to 2203. There we go. So here's where we left off. It's got the approach. We should see the reverse, the braking thrust. It's not really braking much. Didn't even rotate much. Dindle says that is one of your best. I didn't like that. Let's try again. Another go to 223. The braking thrust is running me right back pretty much straight up and down. I don't recall that being the case. Let's see if we can figure that out.
That did not appear to be as successful as we've previously seen that.
That's what I thought as well. And I didn't touch this. So I'm like, what? It does not make any sense. I'm almost inclined to refresh, but I shouldn't have to refresh it. All right, let's go. I think I want to start looking at the state. The state is shown in blue. Wait, hold on. Let's launch and do the go-to. There it is right there. So there's the state right up there. Applying approach thrust, applying braking thrust. So I'm looking for when we switch to applying braking thrust. Wait. Nope. Okay. Did you have a good day today, Rory?
I did, yeah. Yeah, started off rather chaotic, but things got solved, and the afternoon has been fairly peaceful, which is good.
Look who's here! Looking sweet. Well, it was till Retro CRT's fanfare started playing. Then Retro CRT's fanfare started looking sweet. We only have it. The reason for that is because it's only showing up on one of my scenes. So that's what's going on. Retro CRT. Yeah. So sorry, I broke the ship. No worries. That's not bad. Okay. Apply braking thrust. Here we go. So, oh yeah, I'm starting to remember this code. We're solving one of these two.
Mm-hmm.
One of these two axes, I think is what it is. The plural of the axis is axis with an ES, I think. Is that true, Roy? Do you have a confirmation or?
I am honestly not sure.
I think that's it. Let's see what I can find. Plural axis. Yeah, that's it right there. Like I've got a couple axes.
Okay.
That's
that
plural.
Works.
Okay, so we decide which one of these two to solve first, based on time to that location.
Mm-hmm.
Yes, we can chop firewood because they're sharp axes. Each axis is sharpened. That was like a little bit of crazy that just brought to you by me.
So yeah, we've got a target X and a spaceship center X, which gives us a distance to the target in pixels, which we then multiply up into meters, so that we can use our physics engine stuff in tandem with, and we get the thrust to displace in order to achieve that. And of course, if we're doing the y-axis, then we obviously start with two different values, but the basic premise is still the same.
Yeah, then we go into tilt to match thrust. Oh, it says left off here. But is that true still? Because it looks like we have not left off here. I don't know, Rory. I'm gonna like save this and I'm gonna go refresh because I recall it being better when we did this.
I don't recall this
Refresh
specific
the tab.
code, but we've definitely seen it work better than it was.
Nope. The braking thrust is really just going straight up and down to 0, which doesn't make sense. Also, it seems like it's I don't know. Let's compare it with intuitively. Let's do it intuitively. Like, intuitively, it's braking too soon.
We
I don't
said
know, Rory.
braking too soon. It's not actually braking.
Well, it's switching to the state apply braking thrust.
True, yes. But having reached that state, it does not appear to actually be braking.
It does not. You know what, Rory? I'm like, I don't want to go into this right now. I'm going to throw everybody a curveball. I'm going to try this instead.
Ooh.
That's what I'm going to try for. Because, you know, I don't know. I'm like, my brain is impacted by the COVID, and I'm kind of like,
yeah.
I don't. Unless you got an idea for push it. You know, we can maybe we'll save this for a sec. Let's go. Let's go open up. Can I bring it up here like that? And will it work? And let's try launching me. There we go. Sweet. Go to. I just wanted to see the additional pieces. Okay, so we're moving. There, now we're braking. Calculating tilt. The new tilt is incorrect. We got a bunch of these problems here. I'm not even sure what that is. I think a change that we made at the end of the last show didn't get compiled, didn't get saved.
Okay.
I wonder if we crash or something. Excuse me. Let's see. The last change we made yeah. So the theta here, the new tilt is looking close to 0 right there. And I recall seeing that before. And I want to try reversing these.
Are we outputting? I can't see where it is there. Is theta being output as radians or as degrees into the console?
You can see by the name of the variable what it is.
Well, I'm just saying we have both. I'm not sure where the output is being done.
I see. You're right. I don't see the output. Where is the output?
Oh, there we go. New tilt. It's a little lower down. It's after the after both. 978.
So that's degrees. That's in degrees then.
Okay.
Let's fix that.
So as you say, that is very close at that point to 0.
Right.
More so than it would be if it were radians.
Let's do this, and let's also, my favorite thing to do with char map is to bring it up and find that degree symbol. You'd think I know it, 176, 0176. And we'll put that in there. And let's see if that flip right there that we just did, because it does match this second formula right here. Countering thrust divided by, and it's the arctan of that. Let's see what happens if we refresh that. Okay, there's the refresh. There's the launch. And go to 223. New tilt is 45. There we go.
Okay, that's
way better.
At least tilting both ways.
Way better. Okay, cool. Let's shut that down. Oh, maybe we should have looked at more of the errors there to find that out. Find out what they are. Let's try it again on the stream. Oh, wait, I've got to refresh. So interesting. We made that change, but I don't know if I crashed or what happened, but that change didn't get saved. Okay, one more time. So this is where we left off. Now it seems like it's breaking way too late.
Yeah. But at least the actual mechanics are in the order you'd expect and the quantity that you'd expect. So it's a scaling matter, or time scaling matter.
Yeah, let's maybe go after, let's launch me again. Go to, let's watch it again. It's like it waits right until I go across that. Let's go look at that code and figure out the braking and why is that braking is taking so weirdly long to do. Interesting. So when I launch, it goes and reapplies that. I'm going to just refresh the cache. The target is still there, is what I'm saying. Okay, so I'm going to take this out right here. And all right, let's look at the braking. I'll stay focused on one thing at a time here. So when we're last at coasting towards target, the brake time in seconds is here, and that's saying the seconds to the target.
Yeah.
And we're dividing it by 2. And the brake time in milliseconds, we convert it. And then we say the next course correction is going to be here.
Mark, what's the technology we're using to put the enumerated states on screen? Are we literally just able to put any text we like up there, or have you got pictorial pieces that are pre-rendered?
No, we're just using a toString on the enum.
Okay, cool. I was just wondering if there's maybe some data in here that we want to put up there alongside that. So not only are we saying what state we're in, but the sort of number of seconds predicted till the next state.
I love it. Let's do it. Let's do it. Let's see, diagnostics. Draw diagnostics. Draw target. This is where we put the text out, right here. I'm going to just put in a couple constants to shift it over a little bit. Offset X is equal to about 10, and offset Y is equal to about 20, maybe 16. And then we're going to add those offsets here and here. Okay, and the text we want to put out is, we'll do this. Oops, let's do an ls. And we're going to say text, diagnostics text, diagnostics text. And we're going to say that's equal to and then we have if this dot next course correction is greater than now milliseconds, then we're going to say, by the way, I love that you suggested this, Roy, because my brain can do this. I got something I can do. I'm like, oh, okay, cool.
I think it was just because we were staring at some of this information, potentially at least, in the console of the browser, and it's nice that we can put this information just on screen in a consistent location.
It's a really good idea.
It's not quite as good in some respects because obviously we lose historical information as the new stuff overwrites it, but at any given moment in time, we can get an idea, is it going in the right direction?
All right, so we're going to say time to next course correction is equal. Here we'll set it equal to nothing. And here we're going to say it's equal to next course correction minus that. And then we want to take that whole thing and divide by 1,000.
Mm-hmm.
That's going to give me my seconds. Right?
Yeah.
Plus, like that. And I'm not remembering how to trim lots of numbers. Will we even have that? I guess we won't. It'll just be up to 4 digits.
Sure.
And then now we're going to have our diagnostics text, which is that. Maybe let's change this to an interpolated string. Okay. Let's refresh that. Let's launch. Let's target. 3, 2, 1. Well, now we know it. Now we know. Boom! Help me! How goes the coding? You know, I'm tired, Weird Beard Dev. I'm like, my eyes are itchy. COVID is like, I'm not gone. So I'm kind of like, I'm tired. I'm a little apathetic. I spent the whole day caring about stuff.
Mm-hmm.
The whole day caring about everything, trying to make things great. And now I'm kind of like, ooh, brother. You know? So, I don't know. That's kind of how I'm doing. How are you doing?
If nothing else, I'm assuming Weird Dev is enjoying that lovely new intro that's there. I've not seen that one before.
I love it. Yeah,
Looking
no, I
good.
made it. Yeah, I was like, the other day I was looking at Weird Beard Dev's Twitter profile, and I was like, oh, he's already got an icon better than the one I was using. Well, I asked him, do you want me to use that? The downside of working at night. Yeah, that's true. It is nighttime over here, isn't it? Yeah, I don't know. I'm going to do my best. I'm going to try to have a good attitude. But you know what, Roy? If you, all I need you to do is say this. Milla, your attitude needs correction. And then that's it. You go, you get a better attitude, Mark, and then come back. Yeah, the new fanfare is pretty sick. I love it. I love it. I love I think your logo looks great with the lit up saber effects in the background.
Does look good.
These numbers are distracting me. I really got to figure out how to drop the numbers.
Trim the
and I forget
excess.
how to-
I mean, we could. All you got to really is calculate how many digits do you want, I guess.
2,
'Cause
3.
It's always going to be. We're going to have our number of seconds is never going to be in excess of 9. So you can just have. You don't even have to calculate. You just take the first X digits, I guess, or X characters.
Oh, I see. Digits.
So substring
string.
5-ish.
Okay.
I'm not sure if it is
Fine.
substring in TypeScript actually.
I think there's a
it's going to
there's
be
a
JavaScript
way to do
related,
it.
isn't it? So it'll be
Limit
splice
digit.
or something ridiculous like that.
That's what I'm looking for. What are you doing? Oh my
There was
God!
a sample right at the top though before this big list. Num equals num2 fixed. Does that help?
Num2 fixed. Got it. All right, fine. And can I do it right here? I think I have to put it in parens, is my guess. That it? And to fix the number of decimal points, 3. All right, let's see what happens now with a refresh of that. And target. Yeah, okay. Good. Okay. Good suggestion, Rory. I like it. It's looking good. My offset X. I'm not liking that. That needs to go out a little more. And I know what you're thinking. Why wasn't I symmetric here? Fine, I'll be symmetric for you. Something else. Oh, yeah, I just need one. I need one out here. So we'll do that. And now, ladies and gentlemen, your host, Mark Miller, has written some diagnostic code. So now the question is, okay, what? Still, what's going on? Why is that course correction off? Weirdbeard says for interpolated strings, you can add colon format after the number to format it. Oh, okay.
Oh, interesting.
We can go look at that. I don't think that's true in TypeScript. Uh-oh.
So many semicolon languages, it's difficult to keep track of which one we're in.
Yeah, I'm going to keep it the way it is because it doesn't look like I'm not really getting anything. I wonder maybe if I tried it here instead. Getting some stuff in IntelliSense. All right, fine. Okay, so sorry, I thought it was C#. Oh, okay. Got it. Weirdbeard Dev. No worries.
So in terms of what's happening, we are definitely applying the braking on the money, as it were, when it says it's going to. Okay, we are tilting. We're saying we're applying the braking at the right time. Whether we're actually braking or not, slightly debatable. And then we bounce, and then there's a second countdown. I forget what the stage was going to be, and nothing appears to alter when that hits 0.
Yeah, I want to still work on the break time. The break time is like, I'm trying to understand. I want to understand why it's not working. Well, no. This is not the right time. Not the right time. No. Really? I thought I was clear. Can you back it up? Back it up, please.
Pudding overload.
The pudding overload. How you doing, pudding? Heard it was time for my show. All right.
What's the magic number 2 on line 804? Is that deliberately half, or is that because 2 seconds?
No, I'm dividing by 2, cutting it in half. So seconds to target X. Let's go look at seconds to target X. It seems like this is get drop time in seconds. Oh. That's based on no acceleration. Okay. So that's kind of a big deal. Main thrust towards target. This is the problem with writing code. Okay, so rotation degrees isn't being used. Let's just start cleaning up stuff that we're not doing in here. Horizontal thrust and vertical thrust are not being used. Ease tilt starts us moving in this direction, right? Our current main thrust towards target is here. So we're doing basically, it says ease tilt. Wait, if seconds to target is less than goal break time seconds, which is 3 right there. This is if we turn it off.
I was going to say, we're supposed to be calculating thrust, except that we've also got a line in there hard coding thrust to 3. 803. And that feels counterintuitive somehow, but maybe I'm misunderstanding.
There's a state change that's happening here. That kind of makes sense to me.
Okay.
I want to see, before we get in here, I want to see how many times this is called. Main thrust towards target. Let's go see when this is set. So 10 times a second, interval between updates is now to here. Do I need to say this dot next course correction is equal to now milliseconds plus interval between updates? I think this is going to already be happening outside of this. Let's see what we've got here. There it is. Right there. Oh, but that's in the old fly mark towards. It is. Oh, here it is. Start course correction. Well. Oh, it's in the old one. The old one is not called anymore. I'm going to take this out so we stop tabbing to next reference on this. It's confusing me. Am I the only one that Coder's doesn't work for Boeing? Why is that? What is that? Oh, because I'm flying? Because I'm not doing a great job?
Coding and if it may be applied to large planes.
Yeah. Do you know my dad worked for Boeing?
Really?
Yeah, he did.
Did you do anything fun?
He was president of the company.
Okay.
And he always would look at me like, what is wrong with you? And be like, Dad, look at me, you know? And he'd be like, dude, you're like in your 40s right now. I'm like, yeah, okay, so that's not helping us at all. Okay, let's look at this. Interval between updates doesn't appear to actually be, so what's going on here? Not used anymore? Okay, can it kill it? All right. Yeah, it's an old targeting state. That should have been my big clue. Interval between updates is not used.
Okay, that was a factor purely of our old system.
Yes. So now we're starting to get a little more insight into why it's taking so long to break. Because it's basically the main thrust towards target is called not at all. Oh my God, we're not even in? Are you kidding me?
That's concerning.
So there's some other code somewhere that's applying the brakes, presumably. Yeah, it's a little bit concerning, isn't it?
Yeah.
Also, we could say it's disconcerting too. Okay, let's look for the braking thrust again. Let's go look for braking. Applying braking thrust. Where are you?
So this method here is our state machine. It determines what state we're in and therefore what state we should be, given that because we've come here, we are supposed to be changing state.
Right.
So if you are the test state, you should change to, or you should execute the code beneath, which may or may not change your state.
Right. That's exactly what's going on.
If we're calculating approach thrust, then calculate approach thrust. If we're applying approach thrust, we should brake. Actually, that was an interesting one.
Sorry.
Is that true? Calculate approach thrust is fine. Apply approach thrust is start braking. Okay, yes, it's just a different way of saying the same thing. That's fine.
What this means is that we are now ending this state. So this state ends when the next course correction occurs.
You say that, but in the previous block, if you're ending calculate approach thrust, then you should still calculate approach thrust?
Yeah, it's correct. Because this one is the first one we enter into.
Okay. I guess that's what I'm trying to figure out is if the tests themselves, the if statements, if they are presuming the end of the being in the state or the start of the being in the state.
Well, yes and yes. It's
Okay.
kind of what's clearly happening. So it's yes, this is the beginning of this state, and yes, this is the end of that state. The problem is, yeah, some states have things that say do something at the beginning of my state, and when I do the course correction and I'm in that state, and some things say when I'm in this state, change the state. I don't know. For me, it's like I understand it's not as consistent as you are a fan of, but in my head, my consistency platform is smaller, and I'm okay with it. In other words, it's like it's when I'm in this state and I've got a course correction, then I do something.
Absolutely,
And
no, that's
sometimes
fair enough. So if this happens because a course correction has been requested, because you have reached the point where course correction of some kind.
Right, yeah.
And then once that has been established, that's the outer condition that gets you here in the first place. Then the question is, well, what are you currently doing? And therefore, what should you be doing next?
Yeah. So let's look at that. Let's come back at this. So now we're going to repeat this, and now we should be in only one place. There it is right there. So here's this code, calculate approach thrust. Okay. And where's my brake time? Here. Total approach time. Time to target in seconds. Get drop time. We are using the horizontal thrust. And the velocity.
I'm just a little confused, Mark. Just before we continue too much here, we've just recently commented out some code which was deemed to be old code that we weren't using, right?
Yep.
Is that not the same code that we corrected in order to get things working, not 5 minutes beforehand?
No.
There was an equation we flipped. Was that not in the commented out stuff?
No, it was not. It was a different place. That place had formulas in it.
Because if that had been the case, all the laws of physics just gone out the window.
Yeah, no, that's in. It had a couple formulas in it. Where are you? Just visually going through it. I don't see it. Was it really here?
There we go. That's
guess
it,
it
and
is
that
there.
is still live code, so that's fine.
Yeah.
Okay, cool.
Good question. Get approach thrust. Now, what does this do? Distance to target in meters. Get thrust to displace. Nominal travel speed, 2 meters per second. Travel time in seconds. We do a distance to target divided by nominal travel speed. Get thrust to displace. So that gets our approach thrust. And then we have a tilt to match thrust. So we might be tilting too far. The problem may not be our time calculation. It could be just that we're tilting, that this method is messed up.
Right. So we're sort of declaring we should tilt the right way, but then we come across this other thing that says we should tilt to match the thrust. And since the thrust is keep you going in this direction, then it's kind of countermanded.
This is what we changed. And I think that this is what we need to focus on if we're going to make this work. And I think I got to break out the formulas. So I'm starting up PowerPoint, flying mark. Okay. Tilt to match thrust. And so we're going to come in here and we have either a horizontal thrust or a vertical thrust. Horizontal thrust is this guy right here, the first one. So let's see here. Tangent is equal to opposite over adjacent. So the opposite is the vertical and the adjacent is the horizontal. So there's my vertical and there's my horizontal. So arctan of that should be equal to theta radians.
Yes.
Let's start throwing some stuff out. Alt 0176. Did it do it? Oh no! It's Edmund! Oh no! It's Edmund! We're late today. I assumed your computer completely melted after yesterday. Yeah, it was not good. I just tried Alt and the numpad 0176. Do I have to turn off numlock? Now Alt 0176. No, that didn't work either. Let's bring up char map. How you doing, Edmund? Right number.
Does it have to be the numeric keypad?
I think so. And I tried both Alt keys, left and right, and it didn't work. So I do have a Colmac keyboard overlay on this. So, all right. So this is tilt to match thrust. Is this doing a constant vertical thrust still? Not in this space. We're trying. What we believe is happening here. Let's show you, Edmund, what we think is going on. We'll do another launch and go to. So we think it's tilting too much because it's zooming way past the place where it should be turning at. So we're at the 45 is what's happening on that. The last change you suggested was, I think, to reverse these, and I think it's in the correct form right now, where we have vertical over horizontal. But when we started the show, oops, let me scroll that down a little bit. When we started the show, we reversed these because it was barely tilting at all. So we're trying to figure that out, and I don't know. Let's try reversing it a second and see if we're better with the timing on it. Let's refresh and launch. Go to. Not much of a tilt there, but it does give us about a 3-second applying braking thrust. Yeah, the applying braking thrust doesn't seem to tilt me as much as I'm expecting. It does get me there, though. Okay, so maybe this is actually not bad. So I think we introduced a problem by reversing it because I was second guessing things. What do I want to do? I had an idea. Oh, I know. It's in the calculation of the, let's look at meters per second. I'm going to look for that here. Nominal travel speed. That's what I wanted to look at. I want to change my nominal travel speed to 4. So we change the travel time because I think we can handle that. Let's refresh again. And I want to see if now we tilt to a more severe degree when we start. We do. I am the great lord of pumpkins. Surly. All right. We had some conflicting commands there.
Yep.
Yeah, Surly says, forget the UFO, fly in a pumpkin. Okay,
Solution
so that's
to all
good.
the problems.
Okay, so let's try it again. Let's watch it. There's a tilt. I've got way more of a tilt, and the braking though. I'm not liking the braking. I'm not liking the braking. Let's look at it again. Tilt. We're braking too soon. Maybe we're braking too soon. I'm not entirely sure. Yeah, it brakes in about 2 seconds is what it's trying to do. Go. And imagine if we did actually get the tilt right. Yeah, it's too soon. The braking's too soon. Well, let's go figure out why the braking is too soon. All right?
Yeah.
So I'm now back to saying, okay, I think that code that Edmund gave us, we've got this code in the same state it was suggested when we left last Thursday. And let's keep looking at this. Start braking. Tilt to match thrust. Get thrust to displace. Tilt to match thrust. Feels like, is tilt to match thrust called from multiple places? It is. Wait, I'm totally like confused. Is this the same place the same method we were at before? Just want to go back here because it looks very similar. All right, actually, one thing at a time. Let me abort that idea for a second, because what I want to do is I want to make sure that we are applying braking a little bit later, I think.
Okay.
Let's double check that. Yeah, I think it's a little later is what I want to do. Let's go look at when we're applying the braking thrust. For the next iteration, I have an idea for getting rid of the state machine for flying. I think constant corrections make more sense. Yeah, you got that? You want to talk about it now, Edmund? Because, you know, this is me. My brain's not working so well. I'm thinking, oh, as soon as Roy leaves, I'll have permission to go. I can go as soon as, all right, wait. Did you start braking is here. Playing approach thrust is here. Next course correction is here. Thrust time. Total approach time here. Time to target in seconds is here. So what are we in? What is this? Calculate approach thrust. So we calculate the approach thrust. So that is our I guess we're not braking too soon. Here's the thing. If we are applying thrust and we've calculated our brake time as half, right? Yeah. All we have to do is reverse our tilt. It's kind of a real easy way out of it.
Yeah.
Right? We could just come in here, and if our target axis is X, let's just try. Well, we do this. What are we doing now? Tilt to match thrust. We do that. Target horizontal thrust. Okay, also new insight on this. All right, new insight on this. So this was the method we were in before.
Yep.
And the insight is that we're going that way, it works, but when we're going the other way, it may not work.
Okay.
So that might be another piece to consider in here. So tilt to match thrust is in here.
Is that down to usually the ignoring of negatives? So we've got a math ABS in there, haven't we? Is that correct?
Yeah, but we also have a math sign right here.
Okay.
So yeah, no, I remember putting this in and putting that in and being like, okay with both of them. So let's go back and put this out here. That's where we were. Let's just see what the theta degrees is and the new tilt degrees is. Let's just see what that is. And we'll do that inside of the a browser window. Okay, here we go. All right, let's scroll back up and look at it. So we have our new tilt's at 32 degrees. That looks good.
Does.
Braking. Theta degrees is looking completely wrong. So we get good numbers here and not so good numbers here. Is what it looks like. We have to look at everything. Good. What do you want to say, Rory?
No, I agree. I mean, it's obvious that we're tilting not quite the 45. 32 sounds about right, that we are indeed traveling that way. what we need is the positive 32 degrees, roughly speaking, back the other way. And why it's down near 0, that's strange.
Yeah. It is. So is it at least getting the sign right on it? Let's see. We go from negative 32 to positive number. We do. So that part is interesting. That's working. This code and this code are both coming, these two statements are both coming from the exact same branch inside of this function.
Yeah.
It's inside this if statement here. They're both coming from the same space. I think we're going to start sending these out.
See, the countering thrust against gravity should be a constant across these two statements. And the horizontal thrust should be, well, our initial thrust to the left, and then it should be, on presumption that we're moving to the right, just the inverse.
Yeah.
So we should be able to observe pretty quickly whether that's actually the case.
Yeah, we should be. If we were geniuses, we could
One of our
observe these
assumptions
things.
is wildly wrong somehow.
No, I'm running with we're geniuses, just maybe not today. All right, here we go. Let's see what we got. There's my 32. And I have a negative 2 is my horizontal.
Thrusting against gravity is constant, as we said. Got a negative
This is
2
off.
left, and then a next to 0 right.
This is the wrong one.
Yeah.
The wrong one right there. Yep. Here's the idea for a future iteration. The spaceship needs a speed vector. Should be based on the distance to the destination. If you're close, you want a slower speed, and if far away, you want to prefer a max speed. I'm on board with this idea, Edmund, so far. You can constantly adjust tilt and thrust based on that arctan. The adjustment should be the difference between the preferred velocity and the actual velocity. Once you're close to the destination, yes, should be based on that difference. The ship will automatically tilt backward to try to adjust to the lower velocity. Yeah, so you're saying you go to, you find the higher velocity. Yeah, I'm with you on it. I'm going to just comment, I'm going to copy that out and have it and look at it again. All right, saved, Edmund. Thank you. Okay, let's go figure out why horizontal thrust is wrong. Yeah, I'm with you. Okay, target horizontal thrust is wrong. Where are we setting it?
I saw a thing saying equals get approach thrust. Not sure if it was in the right place.
There's start braking. It's here. This is, I think, where we're calling it. Start braking calls tilt to match thrust. So let's do this. Let's do that. And Let's do this. And might as well throw out our velocity x.
Yep.
And why not distance to target in meters as well? I'm wondering if I should put a negative number here, just because it's the negative over here, or maybe I should just do, it's weird that I'm doing negative here, not math.abs. I'm just looking at that. That's a little weird. All right, we're going to do this. Let's refresh. Launch. Go to. Okay, so our first set is good. Okay, stop. Distance is 12. Space, this velocity is here.
So maybe it's just how the get thrust function deals with those figures, because they look reasonable. Oh, hang on. No, they look reasonable. What was the previous velocity x in the earlier set? A little higher up.
I'm not sure we were putting that out, because this we're only putting out in the start braking.
Oh, in the braking. Yeah. Okay. Fair enough.
It's our brake time in milliseconds. So that as well. Refresh. Launch. Go to. Hold on. Brake time's about 2 seconds.
Do any of those figures feel off?
Well, that's what I'm looking at. I'm thinking about this, and I'm like, it might actually be right.
So if that's the case,
the horizontal thrust is low, but I think it's low because we're trying to cross it. So let's see, get thrust to displace. Let's go look at the calculation for this. Distance meters minus velocity meters per second. Distance in meters. Did I change it to distance in meters? Am I doing that? Distance target in meters. I am pixels to meters. Yep, that's correct. And my brake time milliseconds. Wait. That's it. Time seconds. I'm passing brake time milliseconds. That's it. Okay. All right.
So over 1,000, and then let's see if that has an effect.
I think it will. Okay.
3 orders of magnitude. That'll do something to a problem, right?
Yeah. And we've got. I think it's in physics. Do I have the conversion in physics? Dot to. No, I don't. Do I have it in math EX? Maybe there. To. I don't. Do I have it here locally? 2 seconds? Milliseconds to seconds. Okay, that's what I got. Okay, break time seconds. Don't let me do that. Make that mistake again.
Mm-hmm.
Roy's like, you're going to do it, Miller. I'm going to try. But, there's nothing I can do. Okay, so now let's go here. Break time seconds, like that. You got to stray this. Uh-oh. Oh, I think I got rid of it. Yeah, it was right there. I just deleted it. Okay, break time seconds. Oh my God. That's probably going to look way better. Okay, and did we fix it down here too? We did, I think, maybe. All right, won't that be awesome if this all works? All right, let's
That'd be good.
Try it on the stream and see how it looks. And let's close this. Someday we should add a type for seconds and milliseconds. We get a TypeScript warning. Can we do that?
That's interesting.
Oh, a type. So it's just, we just pass it in. I like that. Yeah, I'm a fan. Okay, launch. And go to. And now.
Well, we're certainly tilting back an equivalent distance.
Yeah, but it's still not quite working the way I'm expecting it to do it. Let's try it again. Go to. There's the tilt. It says in 1 second or 2 seconds it's going to go. Because it thinks in 2 seconds I'm going to get to there. That doesn't feel right at all. Or maybe it thinks 4 seconds I'll get to there. 4 seconds feels right. I got to tilt.
4 seconds
I can't tell.
Therefore 2 seconds before you
Yeah,
reverse.
there's a fundamental assumption, probably one of the assumptions I made, which is that if I go for half the time and I turn around, it'll, and apply the same force in the other direction, I'll reach the end speed, to the end place that I want to get to. But I think that's false. I think if I go half the distance and turn around, that becomes true. But we need to figure out the time to the center distance point, and that time becomes my flip time. Does that make sense,
because
Rory?
the time taken to accelerate from 0 to an acceleration or a level of speed is the same time to decelerate the same quantity given the same or the inverse thrust.
Yeah. So let's go figure that out. Let's go see where's the transition to this is break time. It's here. So time to target in seconds has been established, but I can't, it's useless to me at this point, I think. What I need is time to half target.
Halfway, yeah.
In seconds. That's what I think I need. Time to halfway to target in seconds is what I need. And so that's going to take my distance.
That's just distance over 2, right?
Yeah, it is. I guess I'll divide by 2. Hold on, target for. It's just here. It's only in the drop time calculations. I don't want to mess with these. I'm pretty sure.
I think you're right, yeah.
Okay, time. So now we've got this guy. And total approach time is now going to become time to halfway target in milliseconds. Okay, that feels better. Thrust time MS is gone. Break time is equal to that. Target in milliseconds. Next course correction is equal to now plus target time to halfway target there. Tilt to match thrust. What is this guy? Thrust time. Why am I dividing by 8? The tilt time is divided by 8. I got it. Because we want to have 7/8 of the move be applying the force in that direction. That's the only reason why we need that. Okay. So that's going to actually then be time to halfway target, MS. Okay, I think that's it. Let's try refresh. I guess if you break in 8s as well, it would work. All right, let's try it. Come on. A little further. Now turn. And now it's get me stopped. Oh, it's still not enough.
That looked better though. It's not quite enough, but you're right.
Why not enough? What's the... Is it the tilt? Is it the time for tilting is not getting us enough time?
So are we not applying thrust whilst tilting?
Well, we are, but it's not being applied instantly in the direction we want to go in. Right? So as we start, we rotate, and it's slowly kind of increasing the thrust in the horizontal direction.
Yeah, which means if we do that in each of the two directions, we get less of the horizontal than we'd actually like by, well, a difficult to calculate quantity, but...
Yeah, so what is going on? Let's, do you siphon off the vertical thrust when tilted? Yeah, kind of. Siphoning off meaning, do we have less of it? We do. We have less, but we can increase the thrust. We have control over the overall thrust, and we're not really touching that yet too much. We're just giving us enough. So what generally happens is we drop in, when we go, we should drop altitude because we just don't have enough effective thrust in this direction. All right,
so
I think we
just
need
multiply our thrust by the ratio between the vertical and horizontal at any given moment.
We do. We're already doing that.
Shouldn't that correct and give us sufficient X for our needs?
No. It's just giving us. We're doing that. We're using the angle to determine the actual thrust down and the actual thrust left or right.
So why are we losing X thrust then?
We're not.
Because we're obviously not gaining enough X thrust to reach the far side.
Right. I think that the reason we're not doing it is because I think it's because of the tilt time. But maybe I'm wrong. Let's look at it closely one more time. I don't know. That tilt time's pretty quick.
It is.
But look, we're not. Well, are we off by a lot? I can't tell. Let's see how far we're off by.
I think we got roughly to the equals sign.
Are you talking about that equal sign right over there?
Well, the one that's just barely off screen now.
That one right there? We got to?
Things moved, but yeah, I think it was roughly there. I'm going to say the center of the ship reaches that far.
Yeah, I'm interested in the answer to the question from a time perspective.
Okay.
So, wait. But that's tilt to match thrust, not the one I want to be in. Is this the one I want to be in? Calculate approach thrust. I think this is it. This is my break time. Time target halfway. So I guess what I'm thinking of is kind of like, what if we made it a little further? Overshoot factor. And let's make that at about 1.1. So I just want to see what do we have to get to kind of stop right about that right space. So we'll say times overshoot factor. Make this easier to read. I'll throw this up on the front like that. And then do the same down here. Let's refresh. All right, launch. Go to. Not enough. Take it to 1.3. Here we go. $1.3 worked.
That was pretty good. So is your theory that same factor will be good almost no matter where we're going to?
No, I don't have a theory on it yet. I just have I'm exploring. I'm also wondering, do we have a problem with scale? Or scale totally, are we isolated from scale? Is what I'm wondering.
I was fairly sure that there was some scale calculations in there.
Yeah.
But I can't remember exactly where.
No, we've got them. What I'm not sure about is if we're entirely isolated. Let me copy this and create a new one called go to 229, like that. And 229 is not gonna have me at about 100% scale. Let's see what happens there. Not enough. So you remember you asked my theory?
Mm-hmm.
My theory is, yeah, no, I don't think it's, here's a 9. So take a look at this. Did we hit the x-axis? We came pretty close actually that time. Just like the time before we were not that close to it. Let's try one more time. 229. Yeah, we come close.
It is.
Let's do 223. Yeah, and it feels like it's, well, it actually seemed about as short that time as this time.
So I'm going to say scale is not obviously affected by this at the moment.
Maybe it is universal. All right, let's take it to 1.4, the overshoot factor. What is going on? Refresh.
I was kind of more wondering though, what about distance? So you're going from a fixed place to a predictable fixed place. If you had to go further with the same 1.4 calculation, do you as well?
And we shoot just over a little bit. I'm sorry, do you want me to change the location, where the target location? Is that what it sounds like?
Yes, so yeah, to see, okay. It's a little trickier, I suppose. If we have that and we get as close to that target, then it means that the stretched distance that we have to go is not affecting things, which is good as well.
So we're going to go to 111, maybe 000. That's the upper left and farthest in, let's do that one. Ah, I'm sinking. Oh, it's pretty good. He's getting me right in there.
Ooh.
Right? So it's that 1.4 to 1.3 does seem to be, let's do 1.35. Just, you know, maybe it is the turn. Maybe it's the turn that's, you know, I don't know. I don't really have a good theory on it yet. Let's try another launch and we'll go to 229, so right up here. There's my stop. Yeah, it looks like it's shooting over just a little bit. One of the things we can do is we can go find, go search for, is it 1080? No. Mark default Y and turn it to 750, just so it starts up a little higher. And then we can see where the X actually crosses and see if it actually is looking the same. So here's go to 229. A little short. Here's another launch, followed by go to 000. Oh, I think it's going to sink down, maybe bounce up in time. There we go, bouncing up. And it's a little short as well. Okay, cool. And then that was 000 is what we just did. Let's launch me again. And now let's go to, I think we did 223 is the last one that we have available. And is this going to show up short? Come up short? No, it actually goes over.
It was an overshoot, yeah.
Yeah, that's too bad. Too bad. Let's see if it's consistent. Yeah, it looks consistent.
Was a little over, yeah.
It's not. It looks like it was less over that time though than the time before. Does that feel true to you or no? Let's watch it one more time. It's dropping down just as we get out of sight. Let's bring
Yeah.
this up even higher. Second, bring up another 550. Refresh. Look at it one more time. 223 is what we're doing, I think. Yeah. Okay. Launch again. 223. Are we consistent?
That's
Kinda.
pretty close.
Yeah. I think we're pretty consistent. Okay. Rory,
Yes.
how you doing, buddy?
I'm doing fine. How are you?
I'm pretty good. I just got my finger on a button over here. Think you know what?
Magic
Do you have to get out of here?
God, you're good, aren't you?
What'd you say?
You're very good. Yes, unfortunately, I do have to. I'm just sort of wrapped up in the ratios. It's impressive to me, actually, that these are over by the same quantity, even when we go to further distances.
Yeah.
I kind of
well,
expected it all to stretch,
really
so,
interesting.
double the
Yeah,
distance, double the error, if you like.
It's interesting, isn't it? Yeah, and the different scales, it all seems to still be kind of working. That's kind of interesting. Let's go back
I mean,
to
the
where
other
we were on that.
possibility is that it is scaling. It is over by more and more and more, but by a scale of itself that just doesn't visibly show. It's such a tiny fraction that it doesn't matter.
Yeah, but that overshoot factor gets us close. What's interesting is we are, I think, are potentially getting really close to kind of homing in on this.
Yeah.
That's kind of where we are. But Rory's got to go, I think, right, Rory?
I do, my friend.
And
yes, absolutely.
I'm going to end the show as well. I'm going to hit the Rory button. Here comes the Rory button. Hey, I'm up here this time. There's Rory. I can almost... Oh, he's gone. Thanks for, hanging out with us today. I really appreciate it.
Always good.
It was my COVID show. I think everybody gets one COVID show in their life. Pudding says, "Come save us again soon." Pudding, I'm gonna shut the show down. I'm gonna get a raid going. We're gonna send you guys over to someone. I'm gonna take the weekend and just relax. I'll tell you that much.
Yeah,
I'm not gonna stretch myself out too much. Whoa! Just some out of nowhere. Save me from Party 10. I love Party 10 now. We'll get Party 10 going again.
He's in the house.
Not me this time. All right, everybody take care. Thanks so much.
Yeah.
We're getting
Enjoy
closer.
Your weekend. We'll catch
We're
you
fighting.
on Tuesday.
We're not giving up. We'll see you on Tuesday, Rory. Thanks so much. This is what we did today. We kicked some serious... What? Oh. Anyway, we kicked some serious... What? How do I get this thing to go faster, man? Oh, that's not the right button. That was not it. How about this? That's what I'm talking about. And then Party 10, kids. And I'll get your raid going.